what's the answer to this? Huh? These are like riddles. It's like how do you rearrange it? No. Let f be a such that from 0 to 17. Let's see. From 0 to 17, it has whatever he did. The pluses and minuses and whatever is what is 8. No. Let's see. From 0 to 17, whatever he did. From 17, well, hold on. From 17 to 20. Okay. Hold on. And then from 17 to 20, here's 20. So here, this is 8. Whatever he did here, from 0 to 17, and then from 17 to 20, it did. Its net of everything that it did here was negative. Was negative what? Negative 3. So the net from 0 to 7, this is 8, and from 7 to 20 is negative. Whatever it did here. 13 through 20. Where is 13 through 20? It did 7. It's positive 7. Positive 7. What is the value of 0 to 13? 0 to 13. From here to here. What did it do in between there? How are we gonna do this? Let's see. I didn't even think I even thought about it. What? Who can explain it to me? What's one way to do it mathematically? Let's see. What did it do? All right. So we want to know what do we want to know? What is the value from 0 to 13? This is what we want to know. 0 to 13. If some way we can manipulate this, how can we manipulate this? Let's do the addition. Let's add these up, no? Yeah. Let's add these up. This one with this one. So if we add those up, that will give us from 0 to 17 and from 17 to 20. Yep. Let's do that. So if we do from 0 to 17 of whatever, f of x dx, plus from 17 through 20 of f of x dx, that will give us what? That will give us 5, no? So now we know how much it is from 0 to 20. The ups, the positives and the negatives, whatever, the positive areas, negative areas, all that is 5. From 0 to 20, 0 to 20. Then we can just go ahead and take away from 13 to 20 to leave us that. Yes or no? Does that make sense? So now then this is from 0 to 17. We could just say from 0 to 20, no? From 0 to 20. From 0 to 20 of f of x dx is, and then minus, because we already know what that is, which is 5, minus from 13 through 20 f of x dx. And so that would give us, from 0 to 20, and subtract from 13 to 20, that gives us from 0 to 13. And so this is f of 0 to 20 was 5, we said, minus from 13 through 20. 13 through 20 is 7. So it's negative 2. That makes sense? Okay, let's go to, this is a long lesson. Let's go to the fundamental theorem of calculus part 1 and the chain rule. Problem 1, find the derivative of each function. So we already should know how to do this, except it wasn't complete what we had done before. The reason why is because what we're gonna say, what we're gonna do right now. So find the derivative of each function. We're gonna take the derivative of this. D dx of this thing. And so here we're gonna get g prime of x. What are we gonna get on the right side? Square root of 1 plus x squared. That's it. That's it. You just plug in x in for t. The thing that it was so we would take it for granted before is that we have to take the derivatives of the upper and lower limits. And it doesn't matter, the lower limit is a constant, so it doesn't matter. But definitely we got to take a derivative of this and multiply it by what we got here. What's the derivative of x? Come on, what is the derivative of x? 1. So it didn't matter before because the derivative of x is 1. So 1 times that, it didn't do anything before, but now we're gonna have where the upper limit might not just be x. It might be some function, no? So not just x. But we should already know this is the answer for this. That is it. So we're good. G prime of x should be just square root of 1 plus x squared. Okay. The square root of x is 1. So it doesn't do anything. Oh, same thing here, no? H prime of x. It should just be, h prime of x should just be sine x over 1 plus x squared. Okay, here we go. This is it right here. So what would be the derivative of this? It'll be k prime of x will equal to we just plug it in, huh? So it'll be secant x to the 4th, because we plug it in for t, x to the 4th. But then now we gotta multiply it. Maybe have parentheses on this by the derivative of this. What's the derivative of that? So this is going to be 4x cubed, and that is the derivative. So before when we were doing this, is because the upper limit was always just a variable x, and we take the derivative of x is 1. We never really cared for it. But now that the upper limit is not just x, but x to the 4th, we got to take the derivative of that, and that's not going to be 1. Okay, let's go. Continue on. D. So this one's going to be h prime of x. Okay. So we're going to plug in for every t 2x. I'm using brackets for it. And then we got to take the derivative of that, and let's put that outside now here too. And now it's just a bunch of algebra here. H prime of x. 2 squared is 4. 4 times 3 is 12. X squared. Back to parentheses. 4x times 2. H prime of x will equal to 24x squared plus 8x. All right, let's go to E. I'll give you extra credit if you tell me what the answer to that is already without doing anything. Whatever you, yeah. What? Any guesses? 0. Why is it 0?
Take it right from top and bottom.
Okay. But you could like it's a linear function, no? It's 5t, and I think it's 5t with the so it's slope of 5 over 1, and you're going from negative to, so this area will cancel with this area. That's another way of looking at it. Symmetry, no? But yeah, what we're gonna do here, if we're gonna follow what we just said, g prime of x, yeah. So g prime of x will equal 2. So let's go ahead and just plug it in. 5, yeah. Plug it, yes, 5x. All right, let's go. 5x, just plug in. What the derivative of x is 1, so we just, okay, let's put it there. And then we're going to subtract, because we do subtract. You have to subtract. We're going to plug this in. Let me put parentheses around or brackets. We are going to plug in negative x in for t. 5x, t has become negative x. And then the derivative of negative x. What's the derivative of negative x? Negative 1. So, well, then in the inside, this becomes positive. A negative times a negative is a positive. So then we got it's gonna be negative 5x, and we got 5x. And 5x minus 5x is 0. This is like using the properties. Don't worry too much about this, right? But I mean, This is using the properties, this part, but this is directly where I went to here. Let's go to F. Why don't you guys do F on your own, see what you got on that. Just a lot of algebra here. Minus 8 is what? Is it 19?
Yeah.
Problem 2 here. The graph of the function g, the closed interval from 0 to 10 consists of 4 line segments as shown. let f be the function defined by f of x is equal to that. What is the value of f prime of 3? There's two parts to this lesson. We'll stop after this one, I think, and then we'll do the second part later. You can copy down the graph in a minute. Let's already get started. So we're just gonna take the derivative of this because we take f prime. So let's take the derivative f prime of x will equal to g of x squared, because t is x squared, g of x squared times what? 2x. That's it, no? And just plug in f prime of 3. F prime of 3. So f prime of 3 is going to equal to g of 9 times 6 g of 9. What's g of 9? Because the graph, this is g of 9. So for 24, the answer is 24. Yeah, let's stop it here.